In the last video, I looked at the meaning of an exponent, and in particular, we looked at the case where the exponent is a positive integer when it is 0, and then we extended that to negative integers. So, for example, we noted that if you have something like, say, the base is 2 and the exponent is 4, that means 4 factors of 2 multiplied. Okay, so 2 times 2 times 2 times 2, and that gives us 16. Obviously, something like 2 to the first power, 1 factor of 2, of course, would be 2. And then we showed if you had a power of 0 or exponent of 0, say 2 to the 0, this is going to be 1. And that doesn't matter what the number is. If the exponent is 0, the answer is always going to be 1, as long as the base is not 0. 0 to the 0 is not defined. And then we extended that to a negative exponent. So we looked at, if you haven't said 2 to the 4, say 2 to the negative 4. And by the definition that we went over, this becomes 1 over 2 to the 4th. Or 1 over 16. Okay, in this video we want to look at the case where the exponent is a rational number. That is a fraction. So a rational number is of the form a over b, where a and b are integers, and as long as b, or the denominator, is not 0, because division by 0 is not defined. So the exponent could be 1/2 or negative 1/2, 3/5 or negative 3/5, and so on. Those are examples of rational numbers. And the point here is that the basic laws of exponents that we looked at in the last video also apply if you have fractional exponents or rational exponents. So if you have x to the 1/2 times x to the 1/3. Okay, if you're multiplying powers of the same base, it doesn't matter whether the exponents are integers or rational numbers in this case. The base is the same, you add the exponents. So in this case, we would add 1/2 and 1/3. Okay, so we get the same denominator here, so which is 6. So 1/2 is the same thing as 3 over 6. 1/3 is the same thing as 2 over 6. So we bring down the base and add the exponents. So this will be 5 over 6. Okay. So x to the 1/2 times x to the 1/3 is x to the 5 over 6. Okay, in the same way, if you have something like, say, x to the 3/5, x to the 3/5 power taken to the second power. Okay, a power to a power works the same way as with regular exponents or positive integers. You multiply the exponents. Power to a power, multiply the exponents. So bring down your base, which is x, multiply 2 and the 3/5, you get 6/5. Okay. Now, if you're looking at problems where you have to evaluate, that is, getting numerical answer, and you're dealing with rational exponents, we might want to relate the rational exponents to radicals. So x to the 1 over n. Okay, so the exponent is 1 over n. That's the same thing as the nth root of x. Okay, so the square root of 2 is 2 to the 1/2. Okay, so in this case right here, this is your radical. The the n is called the index, and the number under the radical sign right there, that's the radical sign, and in this case the x is the radicand. So the square root of, so in this case, if it's square root, it's understood to be 2. So we don't put a 2 right there. Okay. It's understood. But if you have anything else, like a cube root, then we have to put a 3 there. So if it's the cube root of x, that becomes x to the 1/3. Or if you have the 5th root of x, that's x to the 1/5, and so on. Okay. Now, using the properties of exponents, or the laws of exponents, let's look at this first expression right here. So I have the nth root of x, and then this in parentheses, that's taken to the n power. So this is the same thing as this. Okay. So now I have to a power. So I multiply by rule. Laws of exponents, n times 1 over n becomes x to the m over n. Now this in turn can be written this way. X to the m over n power is the same thing as x to the n taken to the 1 over n power. Because notice if I multiply the exponents, I get this same thing here. Okay. So in this particular case, then 1 over n means the nth root of what? X to the m. So I can write this as nth root of x to the m. Okay. So that means if I have, let's say, I can write this. Let's suppose we have, well, let's look at this expression over here. Let's look at these problems. Evaluate 8 to the 2/3, and I'm going to do this a couple of ways. Okay. First, I'm going to treat it just like a regular exponent and say this is the same thing as, okay, so 8 to the 2/3 power is 2 to the 3rd taken to the 2/3, and the power to a power, I multiply the exponents. So 2/3 times 3, the 3's cancel, and I get 2 to the 2nd, and then 2 to the 2nd is 4. So 8 to the 2/3 power is the same thing as 4. Okay. Now, if I interpret this as a radical, I have several options. So I can say, right, this is 8 to the 2/3. And looking at these results I just went over, I can look at this as the cube root of 8 quantity squared. Okay. So what is this? Okay, the cube root of 8 is 2, because 2 times 2 times 2 is 8, and then you square it, and you get 4. Okay, same result. Now, by this result over here, this one here, okay, so here I used the first one, that's this one right there, using radicals. Now I'm going to use the second form. This one tells me I can write this as the cube root of 8 squared. Okay, so I can also say then that 8 to the 2/3 power is the same thing as this. Okay, so in this case we square the 8, we get 64. So this then becomes the cube root of 64. And the cube root of 64 is 4. It's 4 times 4 times 4 is 64. So I get 4. Okay. Now obviously in this case I'm getting exact answers. In some cases you'd have to use a calculator. I'll show you in a minute. But here in these examples I can compute it, evaluate it, means find the value. I get the exact answer, but there's somewhere you can't do that. Now the next one, okay, if the exponent is negative, best thing to do first is to write it with a positive exponents. So it's like I said, if it's 8 to the negative 2/3, you can write that as 1 over 8 to the positive 2/3. And of course, we already worked that out. 8 to the 2/3 is 4, so this just becomes 1 over 4. Okay, that's all you're going to do if the exponent is negative. Make it positive using the ideas I went over earlier in the last video, and you can solve it. Okay, the next one then, I can also work it exactly the same way. So I could say 32 is 2 to the 5th. Okay, 32 is the same thing as 2 to the 5th. Okay, so I can write this expression then as 2 to the 5th, and it's taken to the 3/5 power. Okay, power to a power, you multiply the exponents. Okay, so 5 times 3/5 is 3. So this gives me 2 to the 3rd, or 8. Now, had this been a 32 to the negative 3/5, then it would still go through the same calculations, except this would then be the denominator, and the answer would be 1/8. Okay. Now, if I decide to do it just like the last one, if I decide to do this or work this out using radicals, I could say, okay, based on what we've done, I can take the 5th root of 32, okay, the 5th root of 32 is 2, and then cube it. And that gives me 8. Okay. And then the other thing I could do is say, okay, take the cube of 32, and then take the 5th root of that. Okay. So I'm going to get my calculator here. So 32 to the 5th power, or to the 3rd power rather, is 32,768. Thirty-two, 7, 6, 8. And the 5th root of that, is 8. Okay, let's confirm it by using the calculator. 8. 8 taken to the 5th power, okay, is 32,768. Okay, so see, this gives you an option if you're using radicals. This tells me if I have 32 to the 3/5 power, I can take the 5th root of 32 first. I get 2, cube it, and of course I got 8. Or I can take the cube of 32, and I get 32,760. Then take the 5th root, and I still get the same answer. But you can see it's a little bit easier. The calculations are a little bit easier, especially if you're not using a calculator, to take the root first and then the power. Okay. And had this been a 32 to the negative 3/5, the only difference is the answer would come out to 1 over 8. 1 over 8 because of the definition. Okay. Now let's suppose you had something like say 8 to the 1 over 7 power to the 1/7, which is the same thing as the 7th root of 8. Well, here I can't get an exact answer. I could get an approximation, but I would have to use a calculator. So in this case, I would just enter the 8, take it to this power, 1, 7, hit enter, and I get this value right here, 1.345900193. Okay, and I would round that off accordingly based on what they tell me. Now, if this had been a negative 8 to the negative 1/7, then the only difference is that this would be 1 over. Okay, so the answer would be 1 over 1.345 and so forth. And then you could divide it out and round your answer accordingly. Okay, whatever they ask you. Okay, so this is just a short video on how to deal with rational exponents, and I hope this helps you, and we'll see you in the next video. Thanks for watching.